All right, thank you. So yes, then I will start with first the presentation, a bit on what I'm going to talk about in this workshop, and how it will be structured. So the topic of today's workshop is debugging and troubleshooting in R. And one way of defining debugging is being the detective in a crime movie where you are also the murderer. But still, it's something that we surprisingly often do ourselves. At least I do. So the outline for this workshop, first I'll give this presentation, which is more or less half an hour, and it will be about a 5-step strategy on how to deal with problems in your R code. And then I will do a troubleshooting walkthrough, and then we can follow up with some questions and discussions at the end. So as an introduction, also a little bit of why I'm now giving this workshop, is that I think that dealing with unexpected problems and errors in your code happens very often. At least I would almost think everybody that whenever you work on a code, things tend to go wrong. You have to see where it goes wrong and how to fix it. Sometimes this is easy, sometimes this is hard, but it's something that I tend to do on a daily basis. But I rarely see it included in any introductory or really any courses. So at the last physical Cleon meeting, there was this call for people to give workshops, and I thought, well, maybe I can try to do something like this, because I think it's important, not only because you do it often, but also if you are confident in debugging and troubleshooting. I think that encourages you to try out new things, because you know that even if you've not done something before, you can probably figure out if something goes wrong and how to fix it. That being said, everybody develops their own techniques. I don't think it's something that there's one right way of doing it. But also by no means I claim to be the best at it, not at all. This is just to share some of my own experiences, maybe to give some inspiration for others. But I've also seen people on this very call that I know that are in no way worse at it than me. And that's also why I hope that at the end of this workshop, we can have a small open discussion where you can share your own techniques, what works best for you. And I think it's more than fine to find your own way in this. So here, give a small 5-step approach to deal with errors. And I think it's important to know that I don't try to focus on really specific errors, even if they're rather common, but rather more of a strategy that you can apply to most code-related issues. So in that sense, it might be a bit different from other workshops that you've attended. So this troubleshooting strategy, and in following slides, I will go more into depth of these. It's a 5-step strategy, but I would kind of assume that you've already done the first step of double checking your code. Just if you wrote a line and you may have missed a bracket, or you typed a dot instead of a comma, usually you can, sometimes not easy to find, but I would assume that you've done that step. And then if you still can't fix it, I would say that the first step and most important step is to locate the problem or your error. After that, you can also try to understand the error message that you're getting, which may point you towards a solution. Third, you can read the documentation of a function or a package that you're using. Only then I would tend to try to find help on the internet, see if other people have had similar issues and how they fixed it. And then you can, if that doesn't help, you can think of follow-up steps. And it's not as if you have to go through all these 5 steps all at once. Always, very often you find how to fix your problem after step 0, 1, or 2, and then you can skip the rest. But this is sort of a strategy that you can go through step by step, and if it doesn't work, you can go to the next one. So this first step, I'll do this very quickly because I think everybody does this automatically, and probably most errors are just generated by something that, yeah, you forgot a bracket, a comma, a pipe, etc. You may have forgotten to import a library or load a function. You refer to the wrong file, but these problems can actually create very hard to understand error messages. So yeah, especially if you just wrote a line and you get a mistake, just take the time to read it back, and you probably find something that was wrong there, which you can easily correct. But then actually I will spend most of this presentation on actually step 1, which I think is the most important one. Because if you find where something goes wrong, usually you also understand how to fix it. Not always, of course, but that's actually, yeah, maybe the most critical step, and surprisingly hard if you have a very long script or you're using a function that's written by someone else. And you also, if you want to look on the internet for a solution, you of course need to know what the problem is. So I think this is the most important part of debugging. So in general, you can do this by running your code step by step. You can use the RStudio debugger for this, but you can also just manually do this. Then there are some functions that may help you. There's the debug function. I will demonstrate this also later in the hands-on part of this workshop. There's a traceback function. That's sort of if you use a function that generates an error, but maybe that function calls another function and another function, which makes it very complex to find your problem. Traceback sort of gives you the function that actually or where the error originated. As I said, I will demonstrate it later. And also important here is that it's maybe easy to find what line generated the error, but the real problem may actually have occurred before that. So if you look at this very small code snippet, if you try to calculate the mean of some values and you get this error, yes, your error is generated here, but the real problem is that you do not define the values variable if this if statement is not completed. So I would argue that the real problem occurs here and not so much there. So I would include that in this step as well, like you find where it originates. And that leads to this quote that I find, and actually that it sort of gives the essence of debugging, is finding your bug is a process of confirming the many things that you believe are true. So you start at the top of your function, all your inputs are correct, and then step by step, is everything going the way I think it should go? And then the point that you find the place that it goes wrong is probably the place where you should make some change. So yeah, you run your code line by line. You keep an eye on your environment. Are your variables still looking the way that you think they should? To help you, some people implement some print statements in the middle of the function. So it can just be a print statement like everything's going well. So as long as you pass that point in your function, this print statement will come. So then you can narrow down where your problem is actually occurring. And the other way, maybe a more official way of doing it, is then using a debugger. And this can be done with this debug. You can type debug and then the function name that you're interested in. You can insert, if you want, browser statements, which are sort of stop points in the debugger. Then it runs until it meets the statement. And once you're done, you can undebug the function name. And then your code would run as normally. But once again, you could also run line by line. And I will demonstrate both in the hands-on part. There are some exceptions, or not so much exceptions, but some special cases that I wanted to treat here as well. Sometimes your problem is not related to an error at all. Think of you have a function that makes a nice plot, but it only plots certainly a flat line. You will not get an error, but you still want to know what's going on. So then you need to identify where the problem is that is causing this behavior that's unintended. Which can be actually a bit harder than actually getting an error. So one trick, if you get a warning instead of an error, you can convert them to errors by this code snippet. That means that your code will actually stop at that point and might be easier to find. You can also make an if statement and in combination with a stop function. You can even type an error message in the stop function, which I will also show in the script after this presentation. So if, for example, an empty data frame is created, which you do not want, you can say if number of rows in this data frame is 0, then stop, say something went wrong. And this is maybe more understandable than actually trying to find out where your empty data frame creates an error down the line. If you work with multiple functions that are called, for example, you want to round the result of a square root that you have in there, I would advise to work from the inside to the outside. So first you try to see what the square root function gives you, then you try to see what the round function does. And if you use pipes with tidyverse packages, you would then, that means you would work from top to bottom. And as I said before, you can also use in RStudio, if you get an error, you get a button with show traceback, and that will show you what function is actually causing the problem, which is maybe a faster way of discovering it. Sometimes you are using loops or some grouping operations. In this case, it's important to first try to see at what step the problem occurs. If you use a regular for or while loop, this is rather easy if you get an error, because then the index of your loop will be in your environment, will be the step at which the error occurs. Sometimes it's a bit more difficult, but this would be, or I would see this as the first step. If you get an error while doing a loop, you try to see at what step the problem actually occurs. So then the last part for step one, sometimes there are some exceptions, I would say. So sometimes your error only occurs. Sometimes, I think we've all been there, like I swear my code was working yesterday and now it doesn't. It's a bit more difficult, but I would say a good way of testing if your code actually works is to empty your environment before you run your code. And sometimes you even need to restart R, because then all your loaded packages are removed. So then it's really just the script that you're trying to run, which is being tested. And of course, maybe the problem is then not with your script, but with an interaction with a server or a website. And that may be the part that's causing a problem. I think most of us have seen this error or this message appear as well. It's like our session aborted. So then the problem is you do not get an error message. You cannot rerun your code. So this whole strategy would not really work anymore. I can only say that often these errors are memory related in my experience. So you would need to try to make your code lose yet less memory. Maybe you need to save less heavy large objects in your R code, or maybe try not to grow a variable step by step, but rather try to factorize it. I don't know, I would maybe look into or try Googling on how to make your code use less memory if you get an error like this. And also the other thing that are not really considered here are package installation errors. But actually, similar to debugging, I often find that you need to find the package that's causing the real problem. So you might want to install package A that needs package B, and package B causes the problem. So if you look through the error messages, often you also get some hints there. But I must admit that these strategies do not really apply to these type of issues. I promise the other steps I'll go through a bit more quickly, but I think they are a bit more straightforward. So step 2 would be trying to understand the error message that you're getting. And especially in R, but also Python, for example, an error message is often informative. So they point you or try to point you to a solution. So for example, if you try to read a CSV file and you get this error, cannot open this file, no such file or directory. Well, if I read no such file or directory, then I directly start to think, okay, maybe I'm looking in the wrong folder, or maybe these underscores are actually hyphens. I would go back to my files, see what's going on. So then in this case, the error message actually directly helps you. Similarly here, if you try to divide a variable by 2 and I get this non-numeric argument, okay, maybe variable is not a number. Maybe I've done something wrong before that. So these are occasions where error messages really help you. Some packages actually do a really good job or try to do a good job. So data table is a package I use very often. They directly give some advices of extra codes to run, like is data table, check if this is true, otherwise go to this help file. But it's not always, for example, if you've never used data table, then maybe you do not understand what this part means for use in J. So if you go to more specific R packages, you might have to read a bit more on the documentation of that specific R package to get a bit more information about it. Similarly for ggplot, which is a package many of you will probably use for plotting. Yeah, if you use it, you might already recognize what's going wrong here, because you need to specify the X and the Y that you want to plot. But yeah, missing aesthetics, you might have to know ggplot that this requires an AES function. But if you have used ggplot before, you read this error message, you might directly know what to do. And that can be really helpful. And of course, if you do, I mean, we all do slightly different things. So maybe your work causes a certain error message to come up multiple times, and you might start to recognize what to do in that case. And as a last note, I think this works best in packages or functions that aim to fail fast. I have some recommendations at the end for it. So directly, if you input something in a function, some packages directly check, okay, is this, I don't know, a positive number? Is this a data frame? And if not, they will directly tell you like the argument that you try to use is not correct. And then error messages are often very helpful. Step 3, you should, I think, read the documentation, which is, I think, often skipped, but I would always do it before looking on the internet. So you can do that by typing a question mark and then the function name. Because functions may require slightly different inputs, different arguments than you expect. And then especially, I think you can look at the types or classes of the arguments. Maybe your function needs a vector as an input, and you have a character. And these are things you can usually find well in documentations, although some functions have better documentations than others, of course. And they often also contain an example. Usually at the bottom, they have some lines of code that you should be able to run, unless, of course, something is wrong with the installation. So you can try that, and then you can see, okay, how is this example different from what I try to do, which is something that can be very helpful. Only then I would try to search help on the internet. I should also say, like, these order of these steps, like 1, 2, 3, 4, 5, is something that maybe you prefer to look at the error message before actually trying to find the line of it. I would, however, say like step 1, 2, 3, I would do before looking on the internet, because on the internet you usually get a lot of different ideas, and without really understanding what's going wrong, I think it's maybe difficult to learn what's going wrong with your code and really understand how to avoid it in the future. But if you've tried all these things before, then that would be the time to look for help on any search engine, for example. Of course, you need to understand what the problem is, like step 1. If an error message is generated, you can use this to help your search. So, for example, for a search query, I would usually start with R to make sure that you get solutions for the R language. If you use a specific package, you can enter it. If you have an error message, you can enter it. And then usually you try to describe your problem in general as well, as short and clear as possible. Everybody probably has looked on Stack Overflow before. I usually find that it works rather well. So I could even write Stack Overflow here as if I want specific solutions from that website. But there are other sources as well. It depends a bit on your specific problem. Something I actually haven't really tried yet, but of course this is maybe becoming more and more of an option as well, is to use ChatGPT or some other AI program to help you find your issue. I haven't really tried it before, but I would definitely say, why not? You can try it out. As far as I understand how it works, it will not. If you need more information, if you need to run additional tests, that's not something I think ChatGPT will do for you. But still, I imagine it's really good in finding bracket errors and things like that. So definitely you can try it out. And this is especially if you use specific packages that are maybe not used by a very wide audience. They may have dedicated vignettes, FAQs, or a cheat sheet or a GitHub page where you can look for some specific help. So for example, here I have a cheat sheet for the string R package. I think this is a very good overview. You just get like how the structure of your function calls, what you can do with each different call in a bit of a better overview than maybe a documentation file. So then we come to the last step, which are follow-up steps. Because if nothing has worked yet, I think a lot of people are tempted to spend hours on this one error, but I definitely think there are some additional things that you can do. First one would be to contact colleagues. Maybe some of your colleagues work on similar things as you. My experience, people are often very happy to help others out with code. That's something I would always try to do. For complex workflows, like some packages, they have really example setups. So not just how to use a certain function, but they have an example data set. They have multiple steps that you go through. I don't know if you know the R Lake Analyzer package, but they also have, on their GitHub website or wherever they host their code, they really have some examples that you can go through. And then you can see, okay, maybe their data frame does not have any negative numbers and mine does. So then you can see, okay, maybe what if I remove my negative numbers? Do I still have the same issue? And I find that can be really helpful as well. You can ask yourself on the internet, not just searching, but you can actually ask the question. For this, you can, I would suggest to use the right channel. So if it's a general code thing, you could indeed go to Stack Overflow. But if it has more to do with RStudio, you can go to the RStudio forum. If it's a very specific R package, maybe you can contact the moderators of the package. And then if you ask a question, they often, or it's often good to include a reproducible example. So this is something that other people can reproduce your error. And sometimes they also ask for your session info, which you can get by by typing this function, which then shows what packages you have loaded, what R version you're using, etc. But actually, the most important one or the most useful one for me often is if I really tried everything and nobody on the internet has done something like this, no colleagues can help you, then I'm usually, I mean, maybe you're doing something super novel and it's super important, but actually, in my case, often I'm just thinking about my problem the wrong way. Maybe some of you have had this before. So I think if none of this works, maybe you just try to do the same thing, but in a different way. Maybe you have to take a step back and maybe search on the internet, how can I do this maybe without some sort of for loop, or maybe there is a package that has already done this before. So yeah, changing your approach is something that I think you should always consider as well. So we're going towards the end of this presentation. Here are all the steps again. As I said, the order is maybe not super important, but I do think that with these steps, you are usually able to deal with most problems in your code. And before closing off, I thought it might also be good to have one slide on how to avoid some errors in general, or I mean, you can't completely avoid them, but at least to minimize it, perhaps. Don't do too much in one script. It's okay to split up tasks, to have a separate function, and then call that from within your script. Like, okay, I have this function that calculates an average of several columns. Well, just do that in a separate script, call it in the one that you're working on. I rarely write scripts more than 300, 400 lines, to be honest. If I need more, I might just have script 1, script 2, script 3, which might make it a bit easier to, that I don't have to go through 1,000 lines to find where something is going wrong. Commenting your code will help you to find what you actually did a month ago and or at least what you were planning to do. And then if your code doesn't do exactly the same thing, it might help you to find where the error is occurring. I would also try to copy as little code as possible within a script or project. So not just to copy paste if you have to do something 5 times to have the same code 5 times in your script, but rather use a loop or an apply function. Because then if you maybe make one spelling mistake, or if you have, if you need to fix something, but you only fix it in one place, these loops try to limit the amount of errors that you can get. from that. You can build in some exception handling. So this is something like you have a try catch statement, for example. So if I'm getting an error here, what do I have to do then? So instead of stopping your whole code, maybe you get some follow-up steps from that. Can be helpful. As I said, designed to fail fast. So directly, if you make a function, you can start with some if statements. If, I don't know, you have negative numbers and that would cause a crash, or if your argument is not a number but it's a character, then you can directly throw an error, so you can make your code crash, but with an informative error message like, okay, hey, you should do something else, you should do this or that. And then some a bit more specific advice, perhaps if you're making packages, you can implement automated testing. So every time you make an update, it will run several tests so that your new updates don't accidentally break something that you did in the past. And if you have a lot of scripts that depend on each other, you can also use this targets package. There are some workshops on the internet about that as well, that can help you to make sure that your workflow still keeps working well, even though you have multiple scripts that work at once. So with that, this is the end of the presentation. I think that before going to the hands-on part, maybe some people have some questions that they want to ask. In general, I have some references here that I used to make this presentation. Especially the top one is actually very similar steps that I explained here. Second one is very good on the actual R debugger. So you can check those out as well. And also, as a heads up, in the hands-on part, we'll use data from Lake Erken. I have included them on the GitHub website that I shared with you earlier, but here's a data portal if you want to see how the data is collected. So thanks for that. I will quickly stop sharing to answer maybe any questions, and then we can move to the hands-on part. So I see there are some things in the chat. Okay, so I think Carolina, you had some experiences with ChatGPT. That's really good. Okay, and Rachel, thanks for sharing the link. If anybody has any other questions, can ask them now, but we can also move on to the hands-on part and wait until the end. If not, then I think I will go to the hands-on part. I'll share my screen again. So for this hands-on part, so the link to the GitHub that is shared in the chat will have all the materials. You can download it there. In general, I have this script called Debugging in R script with errors. So that's the script I'm going to walk through now. I will leave it up to you if you would like to code along. I will try to go slowly, or if you just want to watch. There is also a Debugging in R script fixed, I think it's called, where I've already fixed the errors that are in this script itself. So it's not as if you have to correct the script if you don't want to. But of course, the interesting part is perhaps like the steps in between. I should also directly say that I found it a bit difficult to make the hands-on part. I wasn't really sure what to do. So I hope you will find it useful, because I also considered maybe giving groups the possibility to fix some scripts themselves. But actually, I didn't do it for three reasons, because yeah, it's still a script somebody else wrote, and I think we'll know that can be very difficult to just try to understand what's going on. So that might just take a lot of time, and I may not have in this virtual setting the possibility to see what different people do. And lastly, I think a lot of us will generate errors just by ourselves without getting any exercise. So I think you have plenty of hands-on experience yourself. So what I'm going to do is I have these scripts, and I have two case studies, and the first one is something I did at the start of my PhD, and I remembered a bit what errors I ran into. So this is sort of my first version, and then how I figured out how to improve it. And the second case study is something similar. I just, in preparation for this workshop, I just tried to do something remotely complex and made it as good in a first attempt as I could, and then I ran into issues later on, and then I tried to fix them. But yeah, it's maybe a bit vague because yeah, I don't know. I could maybe go too fast or too slow. So please tell in the chat if something is unclear. But yeah, I hope that the focus should be on sort of the strategy, how to figure out what's going wrong and how to fix it, rather than the exact fix that I make. So yeah, with that, we can start. So the first thing I do here is to set my working directory to the location where I have my script. I realized that I didn't ask you to install this RStudio API package, and also if you don't work in RStudio, it might not work. But you could also skip this line. Just make sure that your working directory was set, WD is set to the location of the script, and you can also go to session, set working directory to source file location. That's the only thing this line does. Then secondly, I set the time zone to UTC just to avoid some issues with time zones. This is something I tend to do when working with time series, but also it should not be essential for the script. And then I'm using two packages, but I will say that the errors that we will encounter do not have to do specifically with these packages. I try to focus on errors that can occur with whatever workflow that you do. It's just that I tend to use data table a lot, which is used for data handling. Think of it as if you use a dplyr, our package is similar to that, but just a different way. And ggplots, maybe more of you know, it's used for plotting, which we'll also do just to check if some of the things we try to do are going as intended. So in this first case study, I tried to calculate the maximum wind speed in a certain wind direction. So we'll use, I have this data set from Lake Erken, weather data, and I just wanted to make a function where if I have a minimum direction, a maximum direction in degrees, that it gives me back the maximum wind speed in that direction. So if we have a quick look at our data, we see we have date time. Can also do str, so it's date time in POSIX, and it's the year 2010 essentially. If we go all the way to the bottom, just 2010, and then we have some weather data, of which we will only use the u component of the wind speed and the v component of the wind speed. So this is u is the west-east direction and v is the south-north direction. And then this is the function that I then wrote at the first attempt. So it's max wind in there. It's a function. It requires a vector, a numeric vector of the u, the v, wind, and then you can give a minimum direction and a maximum direction to calculate the maximum wind speed for. So what I first tried to do is to make sure everything is between 0 and 360 degrees, so that we deal with negative degrees or degrees that are higher than 360. So that's what I'm doing here. Then I try to create a data frame where I calculate the absolute wind speed over here, and then the degrees. And the degrees I call a new function, wind vectors to direction, which is a function I wrote over here, which takes the u and the v components, and then essentially first converts the wind direction with a tangent to the wind direction in radians, then gets it to degrees, and then once again make sure it's between 0 and 360, and then it returns the amount of degrees. So if we go back here, I have this data frame, and then I will cut the data frame to the minimum and maximum direction that I want to have the wind speed for. And then either there's no data, then I return NA, or I return the maximum of this wind speed. So it's a pretty short code, but there are already some complex parts in it, perhaps. So this was my first attempt at doing this. So if I load these functions, I will first just test if it works. So if I do that, I give a vector of u and v components. I say I want to have the maximum wind speed between 70 and 110 degrees, and I get this number out of it, which based on the u and the v components looks reasonably accurate. I would trust the data. But then, of course, it's a debugging workshop, so something will go wrong. If I try to apply this to all my data, I get an error. So now we're gonna sort of figure out what's going wrong here, and then of course how to fix it. So I can directly show you this show traceback. So if you get an error in R, especially when calling a function, this button will appear here. And if you click show traceback, you can see that this is the function that I just called. Because I use the data table package, there's actually also the call of the data table package, which I guess in this case that would be this line. You create the data table, can also be data frame, and then it suggests that the actual error occurred in this wind vectors to direction package. So this is something that you can use this show traceback function for. I can also showcase this debugger function that I mentioned during the presentation. So if we want to activate the debugger, we can write debug and then the function that caused the error. So that would be this max wind in direction. So now we've activated the debugger, and then if we run the line that we did before, we are brought into this new window, which you see over here. So this is the function that we just wrote. And then there are several buttons that appeared here on the top. So you can, if you have a very long function, you can run an entire section. But in this case, we will click on this button, which is step into the current function call. And this will essentially run it line by line. So we're in line 2 right now. And then here on the, in my case, top right, you can track the environments over here, what all the values are. So we have our arguments, which you see over here. And then I can click on step into the current function call. And I can just click a step by step through the function. And I can look here on the top if everything is going the way I think it should go. So we click, so far seems all fine, but here was the part where the traceback function suggested that a problem occurred. So if we go here, this looks indeed a bit complex. This is this data table package, but I think if you use data frame, you will get something similar. So here you create the data table. I will just skip it for now, keep clicking. And here we're in this wind vectors to direction function where the traceback suggested the problem is. So I just keep clicking, calculating the wind speeds, no errors, I get a reasonable number. Again, I use this A102 function, but if I click through, I seem to get wind directions in radians. Then I get wind directions in degrees. I don't get any errors so far, seems to be fine. And then at this last step that you see over here, there I get an error. There I get this error, and it says NAs are not allowed in subscripted assignments. So this is the part where it goes wrong. So this is a bit the way you can use the debugger. And also now would be the time to look at the error message, or that's what I would do. And we know it's this line, and it says NAs are not allowed in subscripted assignments. So subscripted assignments, I would then expect that this is the subscripted assignment, I would say, and then they say there are NA values in there. So apparently some wind degrees are NA, and this might cause the problem. So you can debugger and do more there. In this case, I will now do the undebug so that we can run it normally. So just to have multiple ways of handling this issue. And because we're this was the place where we got the error, right? This is the function that we got. So I can now also just put this in my environment. So if I replace the commas by semicolons and I run this, I will now have in my environment the conditions that caused the error. So I can also now go into the function, run by line. So now essentially I'm doing the same thing, but without the debugger. So I click through it, and this was the part where I got the error. So uwind, vwind, those are these values. I can just do, essentially I'm doing the same thing as I did before, but now right here, this was just before we got the error. I can just say, okay, are there any NAs? So NA is NA in wind degrees. And that's true. So it's indeed true that this is causing errors. And of course, if you have some NAs in this statement, then R doesn't really know what to do. We can even see why this is. So which is NA in wind degrees. So now we get some indices of the NA values. So if I then look at, for example, the first index 283 of my input, it's when uwind is 0 and when vwind is 0. So actually, I mean, this is a bit the downside of this workshop, perhaps. Maybe you already saw this coming. If you have no wind in the U and the V direction, of course, you can't really determine the wind in the wind direction because there is no wind. So now it's a little bit, now we come a bit to the solution. So we found what's wrong, and now we have to come up with a solution. And I think there are multiple solutions. You could just say, well, if there's no wind, I will say it comes from the north because there is no wind. But another way of doing it is maybe making sure that this statement will still work if there are NAs. So that would be a way of fixing it. So I can also say if the wind direction in this statement is more than 360 degrees and it is not an NA value. That would, I think, fix the issue. And then I should also do this in the second one, of course. Like this. And then we can now just load this and see if this fixed the issue. So if I reload the function, and then we try to run this. Now, what we tried to do before generated an error, and now we get a value. See, there is a comment in the chat. Okay, has to leave. It's fine. All right, so we can now continue. So we fixed an issue over here, something I had done wrong first, and now I sort of step by step figured out where the problem was, what the problem was, and then actually finding the solution is almost the least interesting part of debugging, perhaps. So yeah, I run this, that works. So now what I want to do, I just want to make a nice plot. I have 8 wind directions, and I sort of say what's the central direction over here, and then I want to make a plot of the maximum wind speed in each of these directions. So we have this max wind speeds, we get the central direction of those wind speeds, and then I apply this function to every of those wind speeds. So I just say what is the maximum wind from the north, from the northeast, from the east, etc. And then I want to plot the results just to make sure that we get something. And then we get this plot. So we don't get any errors, but I have data for all of 2010, and apparently there is no data from northern direction, which is theoretically maybe possible, but it does feel very weird to me, right? Because you'd expect at least some winds to come from that direction. So I would expect to have a bar here And if we go to this data frame, we indeed see we have an NA value. So this is a case that we have something that's not working as intended, but we don't get an error, but we still want to know what's going on. So at least we know it's for the northern direction. So if we look here, this gives us the center wind of 0 degrees. So then this min there value would be minus 22.5. So I would now I would skip. You can do it once again with the debugger. I would now just do it manually. I can type if min there is minus 22.5, max there is 22.5. And then u wind and v wind still have the values that we're using right here. So I can now just step into this function and see what happens. So I can keep an eye on this. And when I run here, I see that because min there was negative, it's converted to a positive number. That's as intended. I can click through it. I can calculate df wind, which also seems to work fine. I can have a look. This looks like a data set I would expect to see. Like we have the degrees of wind direction. We have the amount of wind speed. And then I want to converge it to the minimum and maximum direction. And then we see over here that this df wind suddenly has no more observations. So then this would be the part that we think, okay, something is going wrong. So actually we can go a step back. We can calculate it again. We can see, and then we can start to think what's actually happening over here. And once again, maybe some of you directly see it, because if you have the minimum direction is a very high number, maximum direction is a very low number, then this statement will no longer do what I intended to do, because this condition will never be true if your minimum direction is higher than your maximum direction. So this is something that, once again, I could fix this in different ways. I can maybe even remove this. I can allow negative wind directions. I can have an if statement that sort of throws a warning if my minimum direction is larger than the maximum direction. But in this case, I think we could fix it, for example, with an if statement over here. If the maximum direction is more or less than the minimum direction, we do this, which we've done before. And if not, we would have to have a different condition. And I think the way to fix this is if I make this an or. That means that if the wind direction is more than the minimum direction, or the wind direction is less than the maximum direction, it will keep those rows. So we have our df wind speed. We can quickly test if this works. Now we have a df wind of 1,000 rows, which used to be 8,000 something before. And indeed, if we look at the directions, these are the directions that we want to keep. So this may have fixed our issue. Let's have a look. We can do this again, and plot. And now we do get a bar in an order of magnitude, which based on the other wind directions seems reasonable. So and this would be the part where I think my debugging would stop, because the function seems to work the way I intended. There's probably a lot more wrong with this function that could break, but debugging is something like you try to do something and you start debugging if something goes wrong. So maybe in 2 weeks, I would try to do something new with it and I would find new issues. And that would be the sign for me to start looking into it again. But at the moment, I would be content with the way the function is working. So based on this, we can go to the second case study. And I must admit, in the first case study, I sort of tried to make some mistakes in preparation for this workshop. But for the second case, I really thought, okay, maybe I can just try to do something where I know I will make mistakes because it's slightly too difficult to do it right all at once. And then these were the steps that I actually followed to to fix the issues. So my idea was I wanted to make a function that calculates the depth of an isotherm. So an isotherm is like the depth at which, or usually used in a plot, but like the depth where temperature gets below 15 degrees or 12 degrees. That would be, or you can also do it on a land map. In this case, it would be in a depth profile. So we load a new data frame, this time on lake temperature data. We can have a look, see what it looks like. So the date time, once again, is 2010. Not the full year. It starts in May and it ends in somewhere in October, because this lake is ice covered, so they get the buoy out when when ice comes. And we have different columns for different water depths and water temperature in each value. So what I do quickly here, I won't really focus on this, but I just make sure it's long format. So I use meld and then convert it to numeric, set the order. And then if I look again, now I have date time on the left, then the depth, and then the temperature once again for 2010. And now we have a bit over 1,000 rows. And then the function that I tried to write, once again, it looks maybe a bit much if you look at it at the first time, but actually it's only around 30 rows, 30 lines. So it's not not a too long function. And what the function requires is a depth argument. This is a vector of depth, which should be positive. Then WTR, which is a vector of water temperatures. And then the isotherm itself, which is a numeric, the depth of the temperature for which you want to create the depth. And then I have a statement if I want to remove NA values or not. And then in a rare case that the isotherm is passed multiple times in a profile, it should pick the topmost depth. That was my idea when writing the function. And I did a little bit better job perhaps as in the previous function. I wrote some comments and I have some statements at the start that checks if all the arguments are correct. So this gives an error if the length of dep and WTR are not the same. If I have less than 3 unique depths, it will also throw an error because I can't really accurately determine depth. And this should check if I use any negative depths or if the depths are not in ascending order, just to make sure any unforeseen things are avoided. But you could, of course, also write the function that you, I don't know, convert negative depths to positive depths, etc. I just thought I throw an error if the inputs are not the way I expect them to be. I have also thought about what if the isotherm that you want to calculate is outside of the range of your water temperature profile. So it's midsummer, your water temperature is between 20 degrees and 14 degrees, but you want to have the isotherm of 8 degrees, then it will return an NA value over here. And actually, this is the real part of that calculates the depth of the isotherm. So what happens here? I can quickly do a test. Let's say our water temperatures are 10, 10, 8, and 6 degrees. Then this statement over here will give me the index where the water temperature, and let me quickly also type isotherm. Let's say we want to have the isotherm of 9 degrees. Then this line will give me the index where the water temperature is above the isotherm, but the next index of the water temperature is below the isotherm. So actually shift water minus n will essentially shift my provided vector by one place. So what this function should do is if one temperature is above the isotherm, the next one is below, it will return me this index, or the other way around, if in the rare case that the cold temperature occurs first and then the warmer temperature. So I could run this function, and then the depth of the index where the isotherm is passed would be 2 in this case. So I have this vector, and then I say at the second step, this is the depth after which the isotherm will be passed. So then I have a depth above, I have a depth below, and then I linearly interpolate, and I want to get the depth at which the isotherm is passed. So if I click through this for this very small example, it will not work because I didn't give you a depth. So let's say depth is 0 to 3. Then this small test should give you 1.5 meters, I think. Yes. So this is what the function does. It's a very simple function, just linearly interpolation. But this was my idea when writing the function. Once again, I just did a quick test on data 0 to 7 meters. I have this water temperature profile, and I want the isotherm for 11.2 degrees. And that gives me the 2.3 meters depth, which based on if this is 0, 1, 2, 3 meters, then yeah, I think that is the correct answer. So seems to work as intended. And then I can apply it to the full data frame. And this is something you can do with data table. You can say by date time, and then for every unique date time, it will apply this function. And I'm looking for the isotherm of 15 degrees. So I try this and it doesn't work. So when I first saw this, I also thought, okay, what's going on here? And the first thing that we would usually do is to see where something goes wrong. But I also already see this error message, and it sort of says column 1 of result for group 94 is type double, but expecting type logical. So this is a bit of a difficult case because the error happens while making a group. So I'm not completely sure where the error happens, but would try to find it nonetheless. So I can just try to take one. We go here. I would just see what if I have this date time and these values. Just let's see what the function does. So I can, as my water input, I would then use the date time equals, and then I would try to get the water temperatures that are present for this date time. So I would type 2010, 19th of May, and then I want to have the temperature column. So this would give me this water input, and then I would do something similar to get depth input, just to make sure that I can run through it manually and see what's going on. And this would give me this depth column. And then, of course, we're looking for isotherm is 15 degrees. All right, so now we go back to the function and we just start running it. I will also say that NARM is false as we then start. So I'll run through it. Seems to work fine, seems to work fine. And here we get a warning. So we don't really get the error message that we had before, but we do get something interesting, I thought, because we see this coercion argument of type double to logical, and that looks a little bit like this error message. So I thought maybe I should just check what's going on here, because as I said in the presentation, like this quote, like you just go step by step and you try to confirm something I know that it should happen like this, and this is something I don't expect, so I just want to see what's going on. So any depth is less than 0 or it doesn't ascend. So I run this, I get this error message. I try to work from the inside to the outside. So I do, how does this step inside work? Okay, any depth is less than 0 is false. That's true. That should not be, there should not be any negative depths. And here I get this warning. So once again, look inside, the difference in depth. So these are the steps of the depth. And when I go here, I sort of see something that what I'm testing here is if any of these numbers is true. And that's not really what I intended to do. I wanted to see if something is in ascending order. So what I intended to do, but what I did wrong, is that I think I placed the bracket wrong, because what I wanted to do is to see if any of these differences in depth is less than 0. So now this statement returns false, but at least I don't get this warning message anymore. So that's something that's okay, seems to work. So we're passing that point now. We can continue running the function. This if statement would be true because according to the comments, we are checking for the isotherm of 15 degrees, and our water vector will not have 15 degrees in it, so it would return Na, which is intended. So still, we don't expect an issue here. We can, just for fun, set the isotherm to something that is within this range, say 11 degrees. Then this should return false, I think. Yes. And we can continue running the function just to make sure that I can run through the function, and maybe I encounter this error that was causing my problem. Right, depth index looks all right. No error still. Just keep running. The depth 5.11, and it would return this depth. So I don't really find what's the problem. Actually, I could do a quick check, because based on this error message that I had, it says the result is double, but it expects a type logical. And that made no real sense to me, because depth should be a number, right? So type double, this is our language for a number. That's what it should be. So it should not be logical. So something I could do now, just like if is logical, the depth, then I could make a quick stop statement, say, well, I know something is wrong. Doesn't really matter. So if the depth is then logical and it would return it, there would be an error message now, a different error message that I generated myself. So I can try that, but I actually still get the same issue. So this test didn't really give me something. So then I wasn't really sure if the depth is never logical, and for some reason this function call gives logical, so true, false results. Yeah, I wasn't really sure what was going on here. So this would be the point I could look on the internet, but I also thought I'm returning the depth here, which is never logical, which we just tested, but I also return something here. If the temperature that we want to calculate the isotherm for is not within the range, it returns an Na. So if you actually look at the class of Na, you see that it's logical. So something I had forgotten to do, apparently, is to make sure that the Na that we return is always considered a number. So that was something I got stuck on for quite a long time. But then if we run this and then we test, we get a different error message, which is something that I'm usually quite happy with, because it means that at least something that had to do with this error either got fixed, or I mean, I seem to zoom in on the problem. But it seems that the problem that we had before was indeed maybe resolved by this, but we're running into a new issue. So we have this as numeric. We always return a number now. We know that, but apparently still there's wrong. So we can have a look. We see where the error occurs. So that's in this line where we actually the line that we just the if statement that we just worked around to before returning an numeric Na value. It says missing value where true or false is needed. So actually, that seems to suggest that this min or max function returns a missing value. And then, of course, this test whether the isotherm is more or less than the minimum value would create an NA, an error. So that's something similar that we had in case 1. So in that case, yeah, I could sort of go back to what we can where this issue occurs. So actually, I can do this, for example, by rows with NA, and then you can do something like the row sums of is NA df, and then testing if this is more than 0. So then you get a over here you get a vector of falses and maybe trues. So if any rows with NA, that shows me that there are rows with NAs, and that is true. So I thought I can just go to one of those rows that has NAs and see what happens in that function, because then it always helps me a bit if I just have the inputs that I put into the function to see what's going on, and then so how I want to fix this. So you can say maybe test row is which of these rows with NA is true, and I would just take the first one. I don't really have a good reason to take another one. So now test row is apparently row 3000 or 34,000 something has an NA value. Okay. I didn't know that. And now we can just use the inputs to make, but because it's long format, we need to have, of course, the temperatures from that date. So what I do now is I can look at the date time, and then what date time is test row. So I now get the date time of this row with NAs, and I try to extract all the temperatures. So water, I now get indeed all NAs. There were apparently no data at all on the date. And of course, I also need to have the depth that goes with that, with those temperatures. And then isotherm was still 15 degrees, but maybe it doesn't really matter. So let's see what happens if we use these inputs. Maybe something happens that we did not consider. So still no problem, no problem, no problem. And here we get the problem. We already knew it would occur in this line. So we work from inside to outside. We check the minimum of all NAs is indeed an NA value. So then you get this statement, which will probably cause an error, I think. Actually not, but then you have an if statement that has an NA value that will cause the error. So once again, we found where it occurs, and it actually makes sense to us, right? If we have a condition, we have no data, and we try to determine an isotherm, I would expect that I would return an NA value. And it also depends how we want to handle NA. So I thought maybe I can make a new part in my function that handles all these NA values. So handle NA values, I can say if all is NA of my water temperatures, I could return, in this case, an as numeric NA value, and that would deal with this issue. I could, of course, also think about this handling statement. I could actually make this a bit more wider applicable, or if any if there's any NA and I don't want to remove the NAs, I would also return an NA value, because I cannot determine the isotherm depth if I don't remove the NAs. So if any is NA in water argument and na.rm is false, I think this would handle these issues rather well. So if I can quickly test, all my water values are now NA. this would be true, I would return as numeric NA. Maybe this fixes the issue, but I would, as I said, I would just do step by step, see what's going wrong, and then come up with a solution. And maybe it's not the right solution, I don't know. Maybe there are better ways of fixing it, but at least it might deal with the problem that we currently have. So I would try to run this, and now it seems to run. So that's good news. DF ISO 15 is the data frame we created. So we have our date times. We get a lot of NA values. But if we scroll down, we see that there are numbers appearing. Looks all right to me. I thought maybe I can just make a nice plot out of it. Then you can see if it looks a bit the way you expect. And I would say it does, right? Like we have the depth of 15 degrees isotherm. On the y-axis, we see how deep it goes over time. I think these are reasonable values. I didn't tell you, but the lake that we're looking at is 21 meters deep, but we have only data up to 15 meters. So yeah, this depth range sounds fine. So it seems like it's we fixed the issue. Now I wanted to calculate maybe some isotherms for 10, 15, and 20 meters depth and then plot them. But we get an error again. So this is something a bit weird, I thought, because we applied our function for 15 degrees, seemed to work fine. But then actually, if we look here and we look also at this show traceback, we see that for isotherm is 10, we get an error message. And that's a bit odd, because why would something work for 15 degrees but not for 10 degrees? So it's unexpected, but okay, we should be able to calculate an isotherm from 10 degrees as well. So let's see what's going on. Something else I can just quickly show, something with the debugger. Under this show traceback button, you also have a rerun with debug, so we can just use the debugger again, just for testing. And something that is nice about the debugger, with these grouping operations, I'm directly brought to the line where something goes wrong. And actually, this is the error I put in there myself at the start. So it's this: if I cannot find any index where the isotherm is passed, I throw this error message myself. This is something I put in at the start. So that's good. At least I know what's happening. Apparently, there was no index to be found. And we can also see now this water variable, and we're looking at 10 degrees. There is indeed something where the water variables are getting to 10 degrees, but they don't really go over it. So something I could do now, if I want to, I could say water is and dput water. That means I could now copy it into my environment. Also, actually, dput depth. So I could now just stop the debugger and then say water is these values that I just got. So I know the error is occurring at this step. Then depth, I do the same thing. And the isotherm was 10 degrees. These were the conditions where we got the error. I go back to my function. Everything seems to work fine. And then this would be the part where I get indeed an empty vector. So once again, we found out what's going wrong, or at least where it's going wrong. And now what seems to be the case is that, so if we go back at our water temperature profile, we go to 10 degrees, but we don't go over it. So then actually this statement, which is looking whether one temperature is above and one temperature is below, apparently does not return anything, while this if statement is not really catching this problem either, because it's only returns an NA value if the entire water column is, if the isotherm is lower or higher than any values encountered. So it's something that also we can fix in different ways. I think we can say if the isotherm is less than equal or more than equal. But actually, in this case, I would say if you have a temperature profile and it reaches 10 degrees, maybe we could also consider that already the isotherm. I'm not actually fully aware of the definition of an isotherm, but I think that would also be a good fix. So if we have this statement, I think we can also say if the value, the first value in my that I provide is at or above the isotherm, and the value below is below or at the isotherm, I think that also would be a good statement to define the depth of an isotherm. So now if I make this change and I look at this value in my environment and I would run it again, I now get multiple indices, which would be around this point, I assume. So we would pass this point, we would take the uppermost index, and then we get the depth value, which in this case would be 8. Okay, maybe this is a good fix, but as I said before, maybe you want to have a different way. There are different ways of avoiding a certain error message, probably. So let's see if this fixes the issue then at last. Now it seems to run. I can have a quick look at my data frame. Or we have at the start of the year, we have a 10 degrees isotherm. Later in the year, we also get 15, 20. Looks all right. Then I want to make a plot out of it over a heat map, which I do over here. And at least I don't get an error. I get some warnings, but you get that in ggplot sometimes if you have missing values. And then we get this plot. So we see temperature development throughout the year. We see some dark gray bars where we have some missing temperature data. That's fine. And then we have in the different line types, we have our different isotherms. So we get the 10 degrees isotherm at the start of the year, which decreases. 15 degrees isotherm over here. Based on the color scale, it seems to be correct. And then the 20 degrees isotherm seems to develop throughout the summer, but it's a bit more erratic. And this seems to work fine. So, I mean, it may not be the most beautiful graph you've ever seen. Perhaps you would like that if the temperature is warmer or the entire profile is colder than the 15 degrees, that maybe this line would be here on top, or in this case with the 10 degrees, that line would be here on bottom. There are definitely ways of improving this, I think. But at least this would be a way that I think my function is working the way I intended to at the moment. And this would be the point that I would stop debugging. So yes, I think this would be the end of the walkthrough. As I said before, I'm not sure if this was super helpful, but what I tried to convey is sort of a strategy of what to do if something is not working the way you intend to. So what are the steps you follow up with, and also that there's no real use of having or learning, okay, what should I do if I get this specific error message or that specific error message? Because then you would have to learn hundreds or thousands of different error messages. I think it may be more useful to have sort of a strategy like this. And then I think you can apply this to almost any issue that you encounter in your code. So with that, I will stop sharing my screen. Thanks again a lot for listening. As I said now at the start, I think it might actually be really nice if the people that are here in this chat, if they want to share their own techniques, I would be more than happy to hear them. I think it's always good to hear more ideas of how to deal with them, things like that. I would also be very interested in receiving some feedback. You can also send me an email afterwards if this was helpful or if you have suggestions on how to improve it. Because I think it would be nice to somehow convert this into a teaching module at some point, like for students that are learning how to work in R. And maybe I can do something like that with this. So from that perspective, I would be happy to hear what you think. And yeah, if you have any other strategies of dealing with errors or bugs that I haven't mentioned yet.
Thank you, Jorrit. Well, I just to comment, I mean, I have been, I mean, I'm not an R programmer. I use Python mainly, but I have been using a little bit of ChatGPT to also to debug. And also when you have to, like, I want to do something, and then it gives you a very nice answers usually. I mean, it has some mistakes you have to follow, but what I think is very important if you use ChatGPT is to give like specifically what you want. I mean, you need to know what you want, and then you can ask, and it's gonna give you some answers that could help you. If you don't know, then it doesn't get, like, if you don't really know what you want to do or how you want to do it, then it's really difficult that it could figure it out. I think that's a main point for using ChatGPT or these AI language models.
Yeah, it's definitely something. Actually, if somebody would give a Limnoseries on how to use ChatGPT together with coding, I would definitely attend. I have heard that it may be a bit better with Python than with R because there are overall more Python users, but I know some people that have applied it with R as well, so they definitely could work pretty well.
Yeah, I actually do more or less the same strategy as you, just to put, like, in case of Python, I just put some points that I want to stop the code, and then trying to figure out where is my error, and then understand what is behind that.
Yeah, I mean, I thought I call it debugging in R because I use R for it, but I assume it's the same in almost any language with slight differences on how to use a debugger. But yeah,
very, very useful. Thank you.
Good.
I don't know if someone has some comments. Please, the floor is yours too.
Yeah, please let me know, and yeah, feel free to send me an email afterwards as well if you want to. Hello, Dyke.
Yeah, thanks very much, Jorrit. That was a very interesting workshop. And yeah, just I don't really have any kind of feedback, but I do like the way you kind of focus in on, or you discuss kind of like this idea of functional programming, because that's also something I've done, like writing a function to like do something really specific. So then when it breaks, you know, you're already kind of, you have it pre-programmed what you're expecting the output to be. And I found that very helpful when coding, just in general, just because, yeah, as soon as the function breaks, then you can go, okay, why is the function not working? And that way you're constantly improving a very specified function to try and catch. Because I find to try and catch everything from the outset is very optimistic in terms of trying to actually anticipate all these things that go wrong, but having a function there and just building on in catches is a good way of kind of working through that as well. So yeah, I just wanted to say that's a very useful tool that I also have started using.
Yeah, thanks. Yeah, I really agree. And actually, like the Gotham Tools package that you wrote is one of those things that I would have a project, and then I have multiple scripts where I would try to read data from, well, in this case, this Gotham model, but I would get this complex netcdf file. I would write some lines of code to get the data. But then if I would later discover a mistake in that, I would then have 3 places where I have to fix that. Well, if you use this one package or this one function that you have written, then there's only one place that you can correct it. So that, I think that's an additional advantage of that method indeed. Good. I think if that's it, maybe we can stop the recording and end it here.
Okay,
but yeah, I would definitely be interested to continue the conversation, maybe at Gleon or some other time. Yeah, thanks all for